In order to solve this problem, we first have to start off with Newton's law of cooling, which states that temperature of time is equal to room temperature plus object temperature minus room temperature multiplied by e to the power of negative kt, where k is your decay coefficient. And to start off the problem, we need to determine what k is. So first we plug in what we know from the problem. We substitute those numbers in, and we get 75 equals 70 plus 80 minus 70e to the power of negative kt. So we'll start off by subtracting 70 from both sides, because remember the point is to isolate k. And we get that 5 is equal to 10e negative k 60, with 60 being the time elapsed between 6 p.m. to 7 p.m. Now we're going to divide both sides by 10, and we find that 1/2 is equal to e negative k of 60. Now we're going to need to take the natural log of both sides of these, and keep in mind that the natural log of e is just equal to 1, so we don't need to worry about it, and we get the natural log of 1/2 is equal to negative k 60. In order to isolate the k, we divide both sides by 60, and we find that k is equal to 0.0116, which is the rate at which the body is losing its temperature. And now that we know k, we can use it in our new formula, where the only difference is we now know our k, so we plug it in, and we're solving for t, the total time elapsed. And the new object temperature is 98.6, since that's the average temperature of a body. Once again, we subtract 70 from both sides, and we get that 10 is equal to 28.6 e to the power of negative 0.0116 t. Divide both sides by 28.6, and then we take the natural log of both sides and get the natural log of 10 over 28.6 is equal to the natural log of e to the power of negative 0.0116 t. Now once again, the natural log of e is just going to be equal to 1, so we write the natural log of 10 of 28.6 is equal to negative 0.0116 t. In order to isolate the t, we divide both sides by negative 0.0116, and we find that t is equal to approximately 90.6 minutes, which is the total time elapsed. Now, in order to find the time of death, we just subtract 90.6 from 6 p.m., which is the initial time they discovered the body, and we find the time of death to be 4:29 p.m. and 24 seconds.